Okay, so power is the same power definition that we've looked at in the past. It is the rate at which energy is consumed. For this unit, though, we're specifically looking at the rate at which electrical energy is consumed. And if we just think about this idea, it's still the same symbol of P, remember, and it's just a change in energy over time. So that's the definition we learned in mechanics. But if it's electrical energy, we're thinking about electric potential energy. And we know that if we have a charge that is moved because of a voltage difference, that is just QV. And we know that Q over T is just current. So the end result is the power equation for electricity is P is equal to IV. Now, with Ohm's law, there's a lot of different iterations of this equation. Remember, Ohm's law is this idea that I is equal to V over R. I should be using my capital V's. So you could plug this in. You could get a variation that says P is equal to I squared R. You could get an equation that says P is equal to V squared over R. And so there's just different iterations you can have the power equation. I believe on your equation sheet you just have P equals IV, but you also have Ohm's law, and then you can derive as needed.
Okay, so these are meant to be class examples of the power equation. So just a reminder, the original equation for power that you were exposed to is P is equal to IV. Power is equal to current times voltage. But remember, there's a couple other iterations of this. If we combine this with Ohm's law says I is equal to V over R. And so we can actually get two other equations for power. We can have power is equal to I squared R, or power is equal to V squared divided by R. So those are our three equations that we can utilize for power. And just depends on what we know in the problem. So just identifying what variables you have. So this first example says a 75 watt lamp is connected to 120 volts. And then what is the current through the lamp and what is the resistance of the lamp? So this first 75 watts, that's my power. And then 120 volts, that's my voltage. So the things that I know my power is 75 watts. And I know my voltage is 120 volts. So the first thing I'm tasked with figuring out is what is the current. So I want to know what the I value is, and then I want to know what the resistance value is. So that is my two unknowns that I'm trying to figure out here. So the first part, trying to find the current, that's just going to be from our original power equation. P is equal to IV. Pretty straightforward, and in that I have my power of 75 equaling I times my voltage of 120. Just going to divide both sides by 120. Crunch that number out. Again, hopefully you are doing the right thing and actually calculating this on your own. And when you do that, you should get a value of 0.625 amps. So that's my current. And then the second part, what is the resistance? You can do a couple different equations for this. Now that you know the current, you could use Ohm's law. You could say that your current of 0.625 is equal to your voltage of 120 divided by your resistance. Or you can say, I'm just going to go straight to this equation because I knew my original values. So 75 watts is equal to V squared divided by R. It's kind of up to you. I think for most of you, going back to Ohm's law is probably the easiest because it doesn't involve squaring anything. And so if we say, okay, Ohm's law says I is equal to V over R, that means 0.625 is going to equal 120 divided by resistance. And we would just kind of cross multiply and divide 120 by 0.625, and we should get that R is equal to 192 ohms. Okay, pretty straightforward.